We are back. We're back. It's Tuesday. That means it's RVA webinar day. I'm Charlie Kaufman. I'm the Senior Product Specialist for Ingredient Performance for PerkinElmer's Food Division. So welcome everyone. Wow, 12 participants. That means you're either very bored in quarantine or very eager to learn about fungal amylase. I'm just going to pretend it's the second one. So, like we always say, these are all predicated on not having seen the previous ones, maybe to be consumed a la carte by customers not yet contacted. So these will all get recorded and they're all going to get put on that YouTube playlist page that I posted in the LinkedIn user group a couple of days ago, sometime last week, I guess. And then I think the marketing folks are going to create a little landing page on the PerkinElmer or old Pertin website to just have a central source for all these. So because we don't necessarily count on everyone having seen the previous ones, we'll do a little quick RVA overview. We'll talk about very briefly why performance analysis is important, and then we'll kind of get into it. We'll talk about some of the different amylases that are used in industrial baking and some of the challenges in measuring that activity. So if anybody has any questions, hang on until the end. We'll have some time, but I may be asking my good buddy Daryl Nelson here to chime in for any input, either during question time or during the discussion of actual fungal stuff. So RVA, as we all know, is a little helper robot. It heats and cools and mixes the sample according to the program that you send to its little robot brain. And it measures ingredient performance. That's what it does. If anybody asks you what it does, that is what it does. So it's the industry standard device for starch quality, starch performance, starch modification characterization. Really gives a good characterization of the molecular weight distribution of a starch, and really allows you to quantify, visualize the effects on ingredient performance from stuff like heat damage, overmilling, particle size, enzymes, chemical treatments, all that stuff. Pretty operator friendly. Big library of stock methods, but it's also infinitely adjustable. You can tinker to your little heart's content and just kind of coax out the most descriptive power possible. And yeah, so it's all about descriptive power. And so this is an instance where we refined an existing method that was available for some older technology. And we took the best parts of it and shortened it and made it much more descriptive for fungal amylase activity in treated flours. So could not have done that if you couldn't easily change the test configurations. And from a quality control perspective, especially in situations like we're going to talk about where you're dealing with a low dose treated flour, you just want to make sure that it's normal all the time, that everything that's in there is supposed to be in there, and that any sort of functional components are doing what they're supposed to do. And this is a really easy and scientifically responsible way to do that. So performance analysis, of course, is important. It's the other side of the quality control coin, so to speak. This compositional analysis will tell you what it is, but it doesn't really tell you how it is. And so it doesn't really detect stuff like starch damage, enzyme stuff, relative degree of cook, pasting performance, stuff like that. And so in this instance, as in all instances, we kind of follow the same pattern, right? We start with the incoming ingredients. The RVA can, of course, analyze the fungal amylase itself, just by itself, to make sure that it hasn't been killed with heat or damaged in some other way, hasn't been accidentally swapped for bacterial amylase, unbeknownst to the miller, things like that. And then it can also do flour quality. So everything that goes in is normal, usually means that everything that comes out is normal. And that way, if you identify a problem, you know it's your fault, which is a great luxury to have. So, bacteria, fungus, and malt. Oh my. So amylase, be it bacterial, fungal, or just malt flour, the good old sprouting alpha-amylase, gets added to flour in pretty low doses, and that breaks down the starch into dextrins, which of course are super delicious and easy to eat for the yeast. And that improved yeast activity creates better crumb structure and dough performance and all that good stuff. So people have been doing this in some form or another, either with the addition of malt flour or various other reagents that contain amylases for a really long time. So it's not like some slick modern process. But the dextrins are a small, simple sugar, and they are created at different rates, right? So these different amylases have different enzyme kinetics and sensitivity to temperature and stuff like that. Bacterial amylase, for example, is super duper aggressive. A little of it goes a real long way. And it's something that you would never want to use by accident, like instead of malt flour or fungal amylase. Malt flour is sort of a medium acting thing. For decades now, it's been a pretty reliable way to get the falling number of a flour down into the range that you want, down into that 250, 280 range. And then fungal is kind of a gentle acting amylase, and it has some specific qualities that make it, you might say, well suited to mixing and baking, but it also presents some measurement challenges. So you just throw that fungus in there. But no, it's a fermented extract from an Aspergillus fungus. There are some different fungal sources, but they're usually that one, Aspergillus oryzol. And the dose, like I said, is usually real low, less than 20 parts per million, usually, depending on the application. And then the quirks of fungal amylase behavior are well suited to baking and dough mixing applications. Namely, it dies at pretty low heat. It dies at 55°C. So any action that you get out of fungal amylase is going to be just during mixing, proving, and then early stage baking, and that is it. And it's pretty gentle enzyme wise, and it's pretty forgiving. So you've got a little bit more wiggle room for ingredient addition there than you would if you were using, say, a bacterial amylase. So these same things that I just talked about kind of make it a pain in the butt to measure. So you can't get it that hot. You can't paste the starch and still have it be working. It dies. It dies at 55°C. There is not a lot of it in there, and because it's pretty gentle acting, it doesn't really have a huge effect on the substrate population in a really short amount of time. Right? It needs some time, or it needs optimized buffer conditions and a really favorable optimized substrate to do what it's supposed to do. So it makes it tough to measure, and it makes it especially tough to measure quickly. But as we all know, where there's the will, there's the way. The RVA is usually the right tool for the job, and because you can tinker around and create a little incubation period where it's optimized for fungal activity, the RVA is a particularly well suited tool for this kind of application. So it it actually uses the same reaction conditions as the test that we sought to replace, right? So unlike a lot of RVA tests, this one has a couple of different buffers, and it has a pre-gelled starch substrate just to really amplify the effect of that fungal amylase. So it may seem really annoying by RVA standards, but the annoyance factor for people who have been using the previous test is not increased at all. In fact, because you can prep a lot of this stuff well in advance and keep it refrigerated, there's the annoyance factor is pretty low. So it's got an optimized incubation temperature for fungal amylase. It just hovers right around 52 degrees, I think. We'll see the test configuration table in a minute. But where this one really sets itself apart is at the end of the incubation, there's a little pasting ramp that kills the amylase and pastes out the remaining starch. So this allows you to compare a treated sample or a mystery sample against a blank, where you know that that flower has been untreated. And so as we'll see, this creates two distinct populations across a huge variety of flower mixes. So the treated population and the untreated population are still really distinct. This is pretty short. Repeatability, especially for this kind of test, is excellent. Introducing a pre-gelled starch to any reagent, to any reaction system, is going to increase the variability a little bit, but this by and large still does really well. And compared to the previous technology and the previous methods, this thing is lightning fast. It's super fast, and at 15 minutes, it's fast enough to be used as a positive release. So here's kind of how it works. So we create this buffer solvent using the same reagents that the previous test does. Use the same pre-gelatinized starch. ADM's Pay-Gel is just our current supplier, but you can use any other pre-gelled starch that you like. And the results that you're going to see were collected with dough-tone fungal amylase, and the data set includes a pretty diverse range of flowers. So here's what it looked like. You can see that the first, almost the entire test is just incubation period. And that's because the enzyme is pretty gentle acting, and right at the end you just get a little pasting ramp in at the end that pastes out the starch and allows you to compare to a blank. So there is a longer version of this test that I created that I think was 20 minutes and change long, and that yields even better descriptive power than this 15-minute one. Basically, the longer you have that incubation period, that warm incubation for the enzyme at the beginning of the test, the better separation you get between the two populations. Here's how it looks in practice. So you can see that these populations are clearly separated. There's a big gap between the two. And one way to think about this as you look at it is by what percentage would the highest viscosity, which is to say like the hardest wheat treated sample, have to increase to intersect in that key area with the untreated population, and it is pretty big. It would have to increase by another 40 or 50% or so. So that's just an outstanding separation of population here. And like I said, you can ratchet up the convenience factor for these tests for yourself if you're a laboratory operator, and prepare the buffer in advance, and you can put it in a bottle top dispenser and stuff like that. So the 15-minute test is generally fast enough to be a positive release. If you get too much shorter than that, then the populations start to grow too close together for my comfort. But at 15 minutes, they're still well separated. So, like we always mention, the RVA is a multi-sport athlete, right? Like our good friend Bo Jackson, one of the greatest football halfbacks and greatest left fielders of all time. And so not only does it allow you to evaluate fungal amylase in treated flour, but it can do all of these other amylases as well. So it can help regulate malt flour addition. It can evaluate bacterial amylase by itself. It can do the incoming flour quality, sprout damage, stirring number. That's the falling number equivalent for the RVA. It can evaluate gluten, dry mixes. It can really do a lot of different stuff. So you get a lot of bang for your buck with the RVA. So when we take questions, before we take questions, I want to have I'm going to go on mute and have Daryl jump in here and just talk about from a baker's perspective, what are some of the benefits to using fungal, and how is it handled differently than bacterial or malt flour. So Daryl, are you still on here, buddy? We may have lost him. Does anybody have any questions? You can enter them in the chat, or I'll leave the audio on for another minute here, but I'm going to stop the recording. Thanks everybody for joining us. This is the last grain-based webinar that we'll do for a while. We're going to switch to dairy in a few weeks. And sorry, I must have had my speakers on mute there. Sorry, Dale, did you want to go ahead? I can hear you. Yeah. Yep. Well, thanks, buddy. If anybody has any questions, I'm going to stop the recording now for the sake of brevity, but it looks like we're coming in right at 20 minutes. And I'll leave the audio on. So if anybody has any questions, feel free to chime in. But thanks everybody for joining. Hope everybody's staying safe, staying home, and we'll talk to you next